there would be typically 150 to 256 channels in a multibeam receiver, which may be curved or flat. Now this basically depends whether the system is to be used for beam steering or not. To put it in perspective, for beam steering, the receiver beam forming creates a virtual subarray by adding time delays to it. Now to apply the correct time delays for a given steering angle, the local sound velocity must be precise. Just to distinguish between the two, the flat array receiver provides good side lobe suppression, but the beams get broader with the steering angles. Beam forming itself in it is a complex process and it is more susceptible to sound velocity errors in beam steering. While in the curved array, it provides same beam width at all the steering directions and it is more tolerant to the changes in sound velocity when steering the beam. But on the downside, it is rather inefficient to suppress the side lobe. Looking at it from the user's perspective, in shallow water, nearshore or river surveys, it is prudent to employ the curved receiver array. While surveying in deep waters, a flat receiver is just fine. Now, before we conclude our discussion, a bit on the receiver channel data. Simply stating, minute voltages are generated proportional to the incoming sound pressure level on the receiver ceramics. There are two transformations thereafter which happen. One is the digitization of signal and the other is the application of the gain, which basically is the amplification of the signal. So these voltages are amplified and then converted to digital signals by the analog to digital converter or the ADC card. The voltage generated for each channel is then digitized. The digital signal characteristics are defined by the ADC resolution and also the sample rate, as we had discussed in our earlier discussion. The sample rate could be like a 8-bit or a 12-bit quadrature sampling. At the receiver stage, a time varied gain or a TVG is applied. TVG basically is the gain level that increases over the time during the receive cycle. When we transmit an acoustic pulse, the first returns are generally those from the closest surface, which usually are the nadir beams. These are much stronger, generating much higher voltage amplitude than those arriving later in the receive cycle. The late arriving returns are the most affected by absorption and spreading loss. The TVG normalizes the signal amplitude with respect to the spreading and absorption losses. Absorption is the amount of energy absorbed by the water, which includes the backscatter and the attenuation. It varies with frequency, salinity and temperature. Spreading loss is due to the energy dissipation as the wavefront increases with the range. To give it a perspective, in fresh clean water or in water with a seafloor that is a very good reflector, the absorption and spreading losses are typically low than in the salt water or the water where the seafloor is a poor reflector. The TVG setting for absorption and spreading affect the shape of the TVG curve. The output is tuned to the operating frequency of the sonar system. The next stage to it is the fixed gain amplifier using two operational amplifiers which feed the bandpass filter. So here we conclude our today's discussion. In our forthcoming discussions, we may well discuss sonar processors, which among other things receive and demultiplexes digitized channel data from the receiver and beamforms the channel data. We can discuss the beamforming board, which basically is the heart of the sonar and is also called the alpha data card. The link module which handles the communication and also passes on 48 volt DC to the wet end or the transceiver, the link controller, the transmitting module and its charge circuit, which basically is the energy reservoir of the system. Now what happens? There is a 48 volt input to the transmitter module, but its output is a variable voltage determined by the desired transmitting pulse amplitude, which may vary from 0 volts to approximately 96 volts. I hope today's discussion was interesting and a bit informative. Catch you up later. Take care.